Hey class, Mr. Houston here, and today we're moving on to Chapter 2, Lesson 2, and we're going to, in honor of watching Star Wars all day today, we are, with the lightsaber there, we're talking about Chapter 2, Lesson 2, and we're talking about analyze conditional statements. It's a lot of big words there. Basically what it means is we're going to start moving into getting the wording down, so when we use some of these for proofs, we kind of know what's going on. So what is a conditional statement? A conditional statement is a logical statement that has two parts, a hypothesis and a conclusion. Okay, those are going to be big parts for today, hypothesis and conclusion. The main part, what we're going to talk about, is what's known as a if-then statement. Okay, the if is the hypothesis, the then is the conclusion. Okay, if this, then that. Kind of, if this should happen, then this will happen. And so that's going to be a lot of what we're going to be talking about today. Okay, so the first thing here, got a little example up here. If we look at this one, if it is raining, that is the hypothesis. So if it is raining, then there are clouds in the sky. So based on this hypothesis of if it's raining, then we can conclude that there are clouds in the sky. That is an if-then statement. All right, so the first thing we're going to talk about is rewriting a given statement as an if-then. Okay, so the first one is all birds have feathers. We want to write that as an if-then statement. So one good way is to try to identify what we are talking about, what is our hypothesis, what is our conclusion. And if I was looking at this, I would look at this and say that feathers is our hypothesis, and then birds would then be our conclusion. So if I'm going to write this as an if-then statement, I would say if it has feathers, then it is a bird. Okay, so that is how we can take that statement there and change it into a if-then statement. Let's take a look at the next one here. Let's rewrite it as an if-then statement, and it says two angles are supplementary if they are a linear pair. Sometimes it's nice and easy to see when you have an if. Wow, that doesn't highlight very well. Let's try a different color there. If you already have the word if there, then your if statement will follow right after it. So simply just rewrite if they are a linear pair, then two angles are supplementary. And we've already kind of talked about that. We've already determined that from a lesson in Chapter 1 that linear pair simply means that they are a pair of angles that create a line, and we know that a line is 180 degrees, and that supplementary angles add up to 180 degrees. So together, so that biconditional statement there, that conditional statement there should hopefully make sense. Okay? So, with that being said, there's more to these conditional statements than just if-then. So we're going to look at these three right here. So you have your conditional statement, which is our if-then. You have the converse. Converse is basically just taking the hypothesis and the conclusion and just flip-flopping them. So if the conditional statement is measure of angle A is equal to 99 degrees, then angle A is obtuse. We flip-flop them to say if angle A is obtuse, then the measure of angle A is equal to 99 degrees. The inverse of that is to basically put no or negate in there. So if the measure of angle A does not equal 99, then the measure of angle A is not obtuse. Okay, and then the contrapositive is it's like the inverse and converse together. You put the nose in there, and you flip-flop them. Okay, and sometimes we'll write them, but sometimes they'll be true or they'll be false. It just all depends on what we are talking about. Okay, So the first thing I want us to do is to be able to write these conditional statements, okay? So the first one we're going to write is the if-then statement for guitar players are musicians, okay? And that does not highlight very well. I don't know why you can't see it very well, but so the if-then statement for that, I would personally say that my hypothesis is here, and this is my conclusion. So if, let's say if they play guitar, or however you want to word it, doesn't matter. If they play guitar, then they are musicians. Okay. Now, is that true or false? You know, if I play guitar, am I then a musician? And obviously, yeah, that would be a true statement. Okay? And then let's write the inverse of that. And remember what we said that the inverse was. The inverse, we just flip-flop the hypothesis and the conclusion. So if they are musicians, then they are guitar players. If they are musicians, then they are guitar players. What about that? Is that true or is that false? Can you be a musician that does not play guitar? And obviously the answer to that is yes. So this has to be false. Okay? This is saying that only musicians play guitar, and we know that is not correct. Okay? Then let's write the contrapositive. I'm sorry. Then let's write the inverse. Let me back up here. Sorry. Probably a little confused here, so let me just make sure I clear up here. This is our if-then statement. This is the converse, and then we are going to write the inverse. So again, if-then, converse, and then we're going to write the inverse. And the inverse is just simply when we put a no or some form of no in there, we negate it. So if, and we're going back to the if-then, the original if-then statement. So if they do not play guitar, then, apologize, my handwriting is horrible tonight, then they are not musicians. So see how we just added some form of no in there for that. So is this true or false? Well, if they don't play guitar, then they probably aren't a musician. So we would say this is inherently false. And lastly, the contrapositive is when we combine, we are going to combine the last two statements that we have there. So we are going to combine our converse and our inverse. So we're going to put the no's in, but we're going to flip-flop the statement. Okay, so lastly, if they are not musicians, then they do not play guitar. Okay, so a lot of writing here, so I apologize, but this is, we wrote the if-then statement. The converse, the inverse, and the contrapositive. Is the contrapositive true or false? And hopefully you have determined that this would be a true statement. So it kind of follows form with what we were talking about up here in this one, that the conditional and contrapositive were both true, and the converse and inverse were both false. make sure that you go back and that you look at what each of these are and understand how to write each of them. It will be much easier as we move forward if you are able to understand how each of these are written and whether each statement is true or false. And flip that page over. A key concept here we've kind of talked about a little bit. Hopefully you know a little bit about perpendicular lines. Perpendicular lines are lines that intersect and then they intersect to form a right angle. So notice how L and M intersect, and they have that little square there, which means that they intersect at a right angle. And remember, mathematicians are so lazy that we can't write perpendicular out, so this little symbol right here means that L is perpendicular to M. Okay, so circle, highlight whatever you want to do to this concept so you understand it when we need to use it here, probably very soon. Okay, all right, example 3. Decide whether each statement about the diagram is true. Explain your answer using the definitions you have learned. Okay, so if we look at letter A, it is saying that line AC is perpendicular to line BD. Okay, is this true? Is this false? And how do we know? So remember up in the definition, in order to be perpendicular, they have to intersect at a right angle. So if we look over here, we have line AC and we have line BD. They intersect at point E, and we notice that there is a right angle mark right there. So we are able to say that this statement is 100% absolutely true. Okay, and we would know that based upon the definition of perpendicular lines. All right. What about letter B? Angle AEB and angle CEB are a linear pair. So we have AEB, which would be located right here, and then we also have CEB, which would be the one right next to it. Are they a linear pair? I mean, if we look at it here, there's a couple of ways to approach this. We know that this right here, line AC, is a line, which means that the angles on it are going to add up to 180 degrees. So we would say, yes, this is true, because we know that a linear pair are also supplementary, so those add up to 180 degrees. Okay, the last one, we haven't talked really too much about opposite rays, but let's take a look at it here real quick. It says ray EA and ray EB are opposite rays. So we have ray EA and we have ray EB. The one thing that we have talked about a little bit is that opposite rays go in opposite directions with the same endpoint, so this would be false. In order then for be opposite rays, we'd have to have EA and EC, or EB and ED. So because that we had this one and this one, we're going to call that false. Okay? And that's just, we're just starting to get into the habit of using definitions to prove what we do and do not know about certain things. Alright, so last one, write a biconditional statement. So write the definition of perpendicular lines as a biconditional. So a biconditional, let's flip back. Actually, you flip to the front page. I lose all my recordings if I try to flip back to the first page. But a biconditional just means it contains the phrase if and only if. So we want to write the definition of perpendicular lines as a biconditional. So let's take a look again at what the definition is. Okay, perpendicular lines, two lines intersect to form a right angle, then they are perpendicular lines. So let's write that as a biconditional using if and only if. So we could say something to the effect of, we could say something like two lines are perpendicular and we have to use that special phrase if and only if. So two lines are perpendicular if and only if. How do we know if two lines are perpendicular? There's only one way to tell if intersecting lines are perpendicular, and that's if they intersect at a right angle. So two lines are perpendicular if and only if they intersect at a right angle. So there's a lot of things going on in this video, so make sure that you go back and you look at all the definitions and that you understand everything we talked about. We talked about if-then statements. We talked about inverse, converse, contrapositives, biconditionals. Make sure you understand each part of that and that you're able to write at least one statement in the different ways that we have talked about. Hopefully you will bring lots of good questions with you to class, and just be prepared, as this is the start of proofs and they are going to be pretty intense when we get into them. All right, so bring your questions to class and we'll see you then.